All right. Hi, everyone. If you're here, hopefully you're here for the SIG CLI deep dive. I have some slides prepared on various topics, but I'd also like to hear what you guys want to learn about and be able to facilitate a discussion as well while we're here. So who is here because they want to learn how to contribute to kubectl? Okay. Sizable number of us. All right. Who is here and would like to learn more about the design concepts behind kubectl? Okay. Great. Well, that's what we're going to talk about. If you have any questions, just raise your hand and remind me to bring the mic to you, or I'll repeat your question. Just absolutely interrupt me. If you're Aaron, you don't even have to raise your hand. You just start talking, and I'll shut up. All right. So here's some of the possible topics. I don't have slides on all these, but I'd be happy to talk about any of them. So if anything up here piques your interest, there's a Q&A session at the end that we can dive into. The first is about YAML composition, like raw YAML composition, and how to manipulate it. kubectl has some commands for authoring YAML. The create commands, subcommands are actually these. So if you do kubectl create deployment, what that actually does under the covers is create like a JSON or a YAML, and then send it to the API server. But if you do create deployment -o YAML -- dry run, it actually just prints out the YAML that would have sent to the server. So that's a nice way of bootstrapping your YAML config. Who here is familiar with kubectl apply and how it's different from create, and also how it's different from like kubectl run and that stuff? Okay, a couple of us. All right. Who here is familiar with the difference between the imperative kubectl run and kubectl create deployment commands versus like kubectl create -f on some YAML file? Okay, I'll talk about that for a sec. So there's two ways of creating objects with kubectl, typically, or two tracks. The first is I want to use Kubernetes like I use a Unix command line, right? Which is I type in a command and then it goes and does something. So kubectl run will go create a deployment for me. Kubectl expose will go create the service for me. Kubectl create secret or create config map will go read in a file and then create that in the cluster. And it works a lot like you're used to with grepping or other commands, right? There's no declarative persistent file that you're working with. There's another set of commands, which is really how everything works under the covers, which are the kubectl create -f, you give it a file. Kubectl apply -f, you give it a file. What this is much more like working with computer code, right? Where you write out the stuff you want, and then you run a compiler command, and then it goes and like makes the thing real at that point in time. I should probably disable this. All right. Hey, Munchie, you want to come up here and just make sure that doesn't happen again? Just move it around every once in a while, and then you can answer some questions with me. Thanks, man. I was a little bit joking, but a little bit serious. Just every once in a while, maybe move that. Okay. So the canonical way we encourage people to use the system, if you want to have like a nice production workflow, is to use this declarative approach, the code style approach. We call it config. What this allows you to do is you have a nice checked-in record into your version control of what you actually want running in your cluster. And that has a few nice properties. One is if you make a mistake, you can actually look at the commit history and then roll it back and figure out who did it and when, and pair this to the red lines on your alerts going all the way off, and you're like, oh, I see what happened. It also allows SREs to review the changes. It allows you to perform a diff more easily. So it has a lot of nice properties, but it is a little bit cumbersome compared to running that nice little command like kubectl create deployment. Okay, I'm done and don't need to worry about it. So the first line here is about if you'd use that declarative approach, which is what we recommend people do, is you start to want some of the same things you have available in programming languages like reuse. Because reuse is really great. And when you're defining configuration, you may want to have some base where you have multiple environments. You have your test environment, your staging environment, your production environment. Maybe you have different regions or different clusters, each with slight variations for one reason or another on some base set of config. And so instead of, if this was the code analogy, instead of having one program that's 1,000 lines, and then you want slight variations on that program, so you just copy and paste that 1,000-line program and then change a couple constants here and there. You really want something where you can reuse that. And so the first piece here is about the tools for being able to reuse raw YAML. I'm not going to go deep into it, but the one thing to take away, if you take away anything, is there's a lot of ways of reusing reusing code, and templating is an example of this. Another example is inheritance and using like the same programming models that you may be used to. And one thing we're trying to figure out is it possible to do it just by declaring the config itself and not introducing new concepts or this sort of thing? Okay, that's probably all I'll talk about on that unless you have more questions. So the other two pieces that I'm going to dig deeper into, and the main concepts behind how we want to write kubectl going forward is how do we do it in a way that supports new API extensions and version skew, right? So when you're writing a CLI, CRDs might be installed into the cluster. How do we make sure that we can work with these CRDs and they look and feel like first-class objects? Or you may download the client and upgrade your cluster, or you may have different clusters running at different versions, but you only have one client installed, and now your client may be one version behind what your cluster is, or your client may be one version in front of what your cluster is. And in these cases, like how do we make sure we write the commands so that they're going to continue to function and you don't need to be pairing the exact version of your client with the exact version of the cluster? And those kind of fall into the second category. So the second bullet point there is about how do we take existing commands like kubectl scale, kubectl create foo, make it so that when you create a CRD API, that those are, you have support for those and you're represented in those commands. The second one is when you create a CRD and you're like, look, I have this CRD, it has this very specific set of business logic I would like to see supported for my thing that doesn't exist for any other APIs. How do we make that available? Okay, so this is just real quick. Our goals, support client version skew, support API extensions. Also, how do we get faster releases, faster development, all this stuff by having the code not as much bespoke code in kubectl, but making it more generic so more people can extend it, and then we can iterate faster. Okay, so real quickly here. Who knows what happens when, and the answer's on the slide, so you can just read it right off. Who knows what happens when you round trip, so read JSON into a Go struct and then write it back out when the Go struct doesn't have certain fields that are present in the JSON. Right, they get dropped. So one thing that we need to be careful of is if you have a command like, hey, set image on deployment, right? And we write that to create the new deployment struct, to use the client to read it into the struct, change the image to the one you specified, and write it back out, and you're on an old client against a new server, and it doesn't have certain fields that are present and set on that deployment in the new server, it's going to delete those fields when you update them, which isn't a great experience. So there's a couple ways around this. The first is to do a patch. So there's a patch API where you just send certain fields, and you say, hey, just update the image field. The second way is there's something called an unstructured object, which just reads it into effectively a map of string to interface. And so then this never actually goes through the go struct, so it doesn't drop anything. And the third is you can just manipulate raw YAML. So these are some of the approaches that you'll see used, and this is why they're used, instead of just doing the simple, hey, update the go struct I just wrote. Okay, so a little bit about generic commands. So we'd like to start writing commands that don't compile in specific APIs. That means that the command can look at effectively the metadata published by the API server that it reads, and then it has all the information it needs. So as you add or remove APIs from the API server, either through extensions or through upgrading or downgrading versions of your cluster, that the kubectl just magically continues to function. And so how do we do this? The first approach is to use metadata about the schema and the structure of the APIs themselves. The second approach is to actually expose endpoints that do the business logic, so the business logic is implemented in the server. So you can either write generic logic that works on a schema, but it's still done in the client, or you can just expose an endpoint that offers a different abstraction layer that you can send a request to. I'll just skip this. Okay. This is an OpenAPI schema. So what is OpenAPI? OpenAPI is a format that gives the endpoints and the schema for the APIs that the cluster knows about. And I just took out a snippet of deployment OpenAPI and bolded a couple pieces. But the noticeable thing you can see here is it has the fields. It has their type. So if the type is like a structure or a complex type, it's a reference, and you can go look that up. It has the description, so you can even print data about it. And we have this cool thing down at the bottom, which is you can have extensions to the OpenAPI metadata. So that means if you're like, gosh, I really wish I could annotate this field on this for this particular API with something like, this is the scale field. And when you scale me, you're updating this number here. Right? That's actually possible through this sort of thing. This particular extension says, here is the group version kind, which is the lookup key for any API for this structure. The other piece of API metadata is something called the discovery service. So the discovery service has just the endpoints. Now this has some overlap with OpenAPI, but it's not complete. So OpenAPI doesn't actually have all the information present in the discovery service, and the format of the discovery service is a little bit different, where it starts out with an object and then has the endpoints for that object, whereas the OpenAPI just has the endpoints as a flat piece. So they're not logically hanging off specific resources. So you can see here, you can ask the API server about all its APIs, and it will say, hey, I know this thing called deployments. It has a kind deployment, which you can go and look up the schema for from the OpenAPI. Here are the verbs that I support. Here's this short name thing, so you can do kubectl deploy instead of kubectl, or kubectl get deploy instead of kubectl get deployments. There's categories metadata, so you can say get all or something like that, and logically group these things together. Okay, so those are the two kind of tools you have for implementing generic client-side logic, where you don't hard code against an API and you just ask, hey, what APIs do you have that have a scale field? Sub-resources are, you can think of them kind of like functions that you can attach to resources. So if a resource has a schema, it's a declarative piece, you can have a scale sub-resource that will go and take some scale field and update the number of replicas for a particular object. And that means that not every resource needs to have the same replicas field look exactly the same, or even be updated exactly the same way, and you can just implement actual business logic and wrap it in this nice interface, and then everyone can your commands can just work against this interface instead of the schema. Here's an example of that. So this is from the discovery service, and you'll get this thing back that says, hey, you can scale this. So you see the name there says stateful set scale, so that means stateful sets have the scale operation, and it has these verbs. So last thing I'm going to talk about is plugins. So sometimes you're not going to be able to implement your logic in these two ways, because you need something that's just really bespoke. You really just want to write your own binary and then have it in kubectl. And so the last piece we're developing is allowing users to just have that option, right? And write whatever code they want and then have it appear in kubectl. And one question we're trying to figure out here is what is the motivation for plugins? Because different people have different things they want to get out of them, right? Some folks want plugins so that they can just implement a kubectl create foo subcommand, right? And that's why, and they just wanted it to appear there so it looks like all the other commands and looks as this nice interface. And that seems to be the common approach, but I think there's some other reasons for people wanting plugins. Plugins could exist as callbacks from actual commands, right? So do you want to swap out this component of how kubectl does something like one aspect of the diff command or something like that? And so instead of being exposed directly, those would actually be invoked to override parts of kubectl. That is not something that we are actively looking at, but it is something people like plugins for, so I thought I'd mention it. One piece that we want to develop is CLI Libraries. So if you're writing a plugin, you don't have to write 200 lines to read in the kubeconfig. That's an exaggeration. You don't have to do that. But there are a lot of simple things that are not trivial to do, and you have to copy this boilerplate code around. It would be really great if you didn't have to do that. So we're looking at how can we publish libraries to a place that folks can vendor them in, and then both use them internally and make them accessible to everyone else. This is something that Matcha and I have been talking about particularly recently as last night at Tivoli. And I think it's a really interesting example of some of the work we're trying to do, right? Because there's a lot of ways that we can approach these problems, and they all have trade-offs. Here, how would you support a kubectl create subcommand for your own bespoke foo resource, right? So if I create foo crd, how do I create a create foo subcommand? So the first would be with a RPC resource sort of driven. So today, if you do create deployment, there is a function that knows how to create a deployment. It registers flags with the CLI. It then reads those into a Ghost struct, fills in the rest of the Ghost struct with some other random stuff, and then that's where you get your deployment. So how can you still write it like that, but not have it compiled into the client? So you could do that on the server side and then publish it, right? So a sub resource, as we saw earlier, you can have the API server publish these sub resources, and you can register a sub resource that's like the create sub resource, and that could have specific fields, and then now the code just runs on the server side instead of locally, right? And you could either have it so that then sends back the YAML so it doesn't have any permissions to write to the cluster, and then your client takes the YAML and then takes the raw YAML, which on the first slide I talked about as an option, and writes that back to the server. Or potentially you could send, the server could impersonate the client and then create it directly in the server. Sub-resource is one way of doing that. That requires having a mechanism for registering sub-resources for your CRDs, which doesn't exist yet. It's being discussed. If you just want to do it on your own, you could probably publish a gRPC or some REST endpoint, and then annotate the create that as a service, annotate the service. Now you can write a program that goes and or label it. Program that goes in, uses the label selector to go find all the services that are create services, reads their metadata, and then sends them. One thing I think that's important here to consider is this should be possible to map flags into a request object. So like flags there's only a couple types they can have, and they're relatively flat, right? You got string, list of string, int, list of int, Boolean, these sorts of things. And so you can just create a flat request that has those things and then map flags directly into that request, and you can register those flags after you've read the request metadata, right? So you can first read what the request looks like, then register those fields as flags, dynamically fill them in, send the request. Who knows what label selectors are, by the way? Okay, so label selectors are essentially a way of applying indexed metadata to resources. So there's a map in an object metadata that takes a string key and a string value, and then that will be indexed, so you can then query it and say, hey, get me all of the services that have the key, I'm a kubectl service, and the value, whatever, right, true, or something like that. The second approach that we've kind of kicked around, there's a little less overhead. So that first one is requires a little bit of thought about how to implement it, right? And we can prototype it, but there's more work there. What can we do that's a little lighter weight, right? Well, one thing we could do is instead of trying to support this bespoke, arbitrary business logic, we could just say, look, what if we just attach a JSON structure to the CRD as an annotation? So an annotation, by the way, is, again, it's another map key value pair of whatever you want, but it's not indexed. So you can just shove a bunch of data in there, right? Not a bunch of data, but you can shove more than you'd index. Don't shove a bunch of data in there. So what we could do, right, is for a deployment, for instance, we could come up with what a JSON struct looks like. For a deployment, you could just run. We could attach it to, if deployment was a CRD, an annotation on the CRD. And then when the kubectl starts up, it could say, okay, give me all the CRDs. I'm going to read off their annotations. Okay, this is here's the JSON for creating a deployment. So now if you say kubectl create deployment, I'm going to start with this JSON. If you don't give me anything else, I'm just going to create this deployment here that you showed me how to create. And then I can register some additional flags that map to like fields using JQ or something, right? And so if you specify -- image, I can use a JSON path to know where the image is and then rewrite that field. So this is somewhat limited in what it can do, but it can actually get you a create command that works and has some basic features. And this might actually be really good having this limitation, because back to my first slide, we really want people to use the declarative way. This is really a bootstrap mechanism to say, okay, you want to do something really simple and easy, and you want to do it fast, and you want to make sure that like you don't have a typo in your config when you're writing it or have to copy and paste it from a page. This will work for that. When you want to start editing, adding arbitrary ports and this sort of stuff, and really modifying the CPU and this sort of stuff, this doesn't work so well. But we'd argue that at that point you should probably, if you care about the CPU that you're running your service with, you should probably be using declarative config, because at that point you probably want more control over it. The last thing is we could just ship binary plugins, right? The disadvantage with this approach is a number of things. If you have multiple clusters, some of which have the API and some of which don't, because either the clusters are at different versions or because the clusters have different CRDs installed, and you got one kubectl binary you have installed, it's not going to work well. It's either going to be present for clusters that don't have the thing, or it won't be. Some things won't have plugins for clusters that do have the thing. You have version skew problems, where now you have like version skew in kubectl is already one of our biggest pain points, and now we have version skew for every other different binary that you've installed, and we're not managing that. And it took us years to really wrap our heads around like the implications of version skew and kind of the mitigating factors. So asking plugin developers to try and like make sure they get version skew correct is Not a nice thing to do. But nonetheless, it's good to know what our options are, and sometimes a bad option is better than no option at all. All right, this guy. Sorry, I was teasing Aaron. Aaron and I are good friends. That's I was teasing him. Yeah. Sorry. Here you go.
That's cool. That's cool. So, like, I don't have a ton of experience writing Go code that interfaces with a Kubernetes cluster. So when I think of how would I write something that interacts with the cluster, I just go directly to kubectl. And it sounds like kubectl, whatever. It sounds like a lot of the problems you are describing are the sorts of problems that anybody who wants to write some binary that interacts with the Kubernetes cluster and deals with version skew and deals with different features and different CRDs and stuff is going to have to deal with. So the question in my head is like this, a lot of this functionality seems like it belongs in client Go. And then I view kubectl as just the like nice UI wrapper over top of that. And this kind of lines up with discussion I keep seeing from some individuals that client Go is too hard to use and we need an easier client. And then I hear you talking about different strategies of like, what if we just use raw YAML and patch it and stuff? So I'm trying to grok just from your perspective, like how much of the work you're describing is inside of client Go? How much of it is you re-implementing stuff, and where do you think it can be done in a way that's reusable for everybody to benefit from these hard decisions? Because I think you're dog fooding a lot of the problems that any tool developer for Kubernetes would have to deal with.
Excellent question. Thank you for bringing that up. We've discussed this, and kind of where we've fallen on it is I'm not going to be opinionated about like what specific repo does this logic go in, right? I do think it should be published and made available, and how that's started into multiple repos. It's actually not that important to me. I think the thing to consider is, are you trying to write a generic tool such as apply that just operates on Kubernetes APIs in general for other people to use, or like a diff, right? And then the answer is yes, that's what I want to do. I want something that operates on resources generically. And gee, it's okay. We don't need the slides anymore. I think, is everyone okay with us not having the question slide up there? You can still ask questions. All right. If that's what you want to do, yes, these libraries would be helpful for you. There were 3 options up there, right? There is patch, there's unstructured object, and there's the raw YAML. And we are still working towards something that's really polished. And there's actually new work being done on the server side to support other options that weren't listed there. Notably, server-side apply allows you to not have to do the patch piece or replace the patch operation. If you are writing a tool because you have, or if what you want to do is really write either a CLI or something that runs in the cluster that addresses some piece of functionality for specific APIs, maybe an API that you wrote, you don't want that stuff, right? If you don't care about version skew, for instance, so if you're a controller, right, and you're running in the cluster, and your controller is packaged with your CRD, so the two are always shipped together, right? In that case, you probably don't want to be working with raw YAML because it's harder to work with and more error prone, and you're not going to have version skew, and you're not going to need to work with extensions. So that's kind of where I'd fall on that. I guess maybe you can think of it as 2 pieces naively, which is the controller, I just no version skew, 1 API, and the totally generic, like it might not even be Kubernetes, it might be just something running raw API machinery code that doesn't know about pods and has totally different APIs installed, right? And there is kind of some stuff in the center where it's like, well, it's for my API, but I do want to support version skew, right? And that sort of stuff, and that's where you need to think about like, well, what happens if we drop fields, right? And is that really bad and that sort of stuff? Or is it okay to tell folks to always run the latest version of the client, potentially, right? And as long as the client is newer, than what's what's being served by the server, then it won't drop fields and this sort of stuff. So, yeah, it's complicated. All right, other questions?
So I was curious. Who is currently making plugins besides Service Catalog? Because that's me. And like, how do you see like some of these future things? Like, how are you vetting out the implementations for them?
Who else is making plugins? All right, that's something I wish I had a better handle on. Actually, maybe we could. Might make sense worth having a community doc or something where folks could register and then get support from one another and discuss. I don't know. Service Catalog has been the party that has most persistently been pursuing plugins, and probably because your use cases align most closely with the plugins. Sorry, what was the second question? Yes.
Well, I was just mostly curious, like some of the things you're laying out for the tomorrow. Like I'm looking at that, and I'm finding it really hard to judge like who you're designing it for. Is it the people who are using plugins now, or is it some other use case that I'm not aware of?
Yeah. Okay. So right, the question was all that other stuff about not plugins, but the other ways. Who is that for?
Yeah.
I'd say we, the contributors to SIG CLI who build kubectl need it, right? In the sense that we need it in order to support version 2 and extensions. We have found and would love to be able to develop our libraries and infrastructure in such a way that they are available to folks who are not SIG CLI contributors. And the reason for that isn't just because we think we can get more mileage out of it, but also because it really helps with onboarding. Like if we've written it so that the documentation is there and the interfaces are there and all that sort of stuff so that anyone can use it outside the project, when you come to contribute to kubectl, you hopefully are in a better spot.
Not sure that's the right place to ask this, but what's the status of the diff command?
This is the right space to ask that. The diff command is going to, the next step for it is going to be to work with server-side apply. So the history behind the diff command, the original motivation was that when you do kubectl apply, it would be really nice to know what that thinks it's going to do before it does it. And we wrote the diff command in the apply logic. We changed somewhat how it was merged for the diff command. So the diff command simulates what it thinks is going to happen, but it's not perfectly aligned with necessarily what's going to happen. Part of this has to do with limitations of apply with version skew, believe it or not. So apply used to use go struct tags to figure out how stuff was going to be merged on the server side, assuming it had the same go struct tags that the server had, right? But when in reality, it might be a version behind, and so missing a field, and then make something up, right? So apply more recently now uses that OpenAPI metadata and the extensions that were listed there to be able to know exactly what the server thinks it's or what the server intends to do, not what it thinks it is. But I think the broader point is right now on the client, we don't have 100% certainty. Yes, I know exactly this is what's going to happen. We just have a like, this is pretty much what we think is going to happen. When apply moves server side fully, which is under active development now, it's like a multi-quarter effort and it's going to take some time. But when it's there, and when the client is then invoking the server-side apply piece, that is going to expose a dry run piece. And then the server can tell us, yes, this is definitely how I'm going to do it. And at that point in time, we'll update the diff command to have that, and it will be more mature. The diff command can also be used for other interesting things. That was the main use case we developed it for. We think it would also be useful for possibly like the customized piece on the first slide where we talked about how do you compose raw YAML together, right? And potentially the diff command could be used, or we could create some sort of diffing logic either in kubectl or in customize or some other place that allows you to diff those things.
So what I would like are two things. First, a unified diff format of what it would do, the apply, and also like diff of the recursive directory comparing the state of the cluster with my Git repo or something, and in unified diff format, so I could patch that.
Oh.
Would that be
have you filed an
theoretically-
issue? Would you file an issue? Or have you already?
Well, I found an issue that's open, and then recently I found there's an alpha feature where you can diff, but that didn't look really like what I was thinking about, so that's what my question is about.
So the recursive directory piece, I thought that alpha diff had. I think the last time I looked at it, which was probably 6 to 9 months ago, it copies the YAMLs, the A and B YAMLs into directories, and then just shells out to the diff program on those two directories, and then displays all the files. So have you tried that?
I think I didn't find that.
Okay, maybe we need to improve the built-in documentation for that. I guess a general tip is if you want your feature or your request or your issue to get attention, GitHub has a lot of noise. And it is really hard. Actually, it's just impossible to really stay on top of GitHub issues in a definitive way. That's not to say we don't try, but it's like UDP, not TCP. If you want a TCP sort of experience, come to the SIG CLI meeting or send to the SIG CLI mailing list. And that's a better way to get engagement. So you can throw an item on the agenda for the SIG CLI meeting, and we usually go through those and we can discuss it. And after that, we'll probably communicate on the issue, but now it's been brought into the cache. We're overrun? Okay, great. Thank you. Thank you for that update.